All right, time now, as you can see in the lower right-hand corner, is 7:49. It is Tuesday, February 25th. We've now moved into the NGC1000 series in the circumpolar rounders exploration. These are all studies I could not capture from the backyard observatory, so I'm having to use my portable telescope with a new imaging system that is clearly superior to the Rev2 system, but does not provide real-time imaging. You have to wait for it to compile an image before you see it, which will prove to be sort of real-time imaging. This is NGC1027. It's at 2 hours, 42 minutes, 35 seconds, plus 61 degrees, 35 minutes. It's in Cassiopeia. I did an image of this earlier from the previous round, so we can do a comparo. We are definitely into sky dark now. The sky looks quite good up there. None of the taint of luminosity from commercial and domestic areas in backyard Tucson. Size of this cluster is 20 minutes through a 17.5-inch telescope, 90 stars, 15 arc minutes in diameter, fairly scattered, but still quite striking. And I would agree, it is quite striking. It surrounds a magnitude 7 star, SAO 12402, and includes about 15 magnitude 10 to 11 stars and many 13 to 14. You can see the 13 to 14s in the background. I suspect on this particular night we could probably image stars down to magnitude 16 plus. This is an open cluster type 3-2P. There's a lot of variation in magnitude, and the stars are moderately compressed with peculiarities in Cassiopeia. Once again, magnitude 6.7 and 15 arc minutes in size based on online NGC catalogs. Okay, the last two clusters, I think it was 1146 and 1169, were too far south to be picked up, blocked by the garage wall. 1146 was at 2 hours 37 minutes, 57 minutes 37 seconds, plus 46 degrees 26 minutes 14 seconds in Perseus. It was a mere point for arc minutes in size. It's an asterism, consisted of about 30 arc-second pair of magnitude 12-13 stars with a couple of fainter companions. So basically it wasn't really a cluster, it was just mistaken for one, and maybe we can see it somewhere on this, well, we won't see it on this screen. And NGC 1169 was, so it looks like it was a galaxy. Once again, we missed our galaxy. It was at 3 hours, 3 minutes, and 34.7 seconds, 46 degrees, 23 minutes, and 9 seconds in declination. We just lost our connection briefly. In Perseus, visual magnitude 11.3 would have been very nice. Size 4.2 by 2.8 with an average surface brightness of 13.8. Position angle of 28 degrees. Through an 8-inch scope done in 1984. Faint, very small, slightly elongated. Only the core was visible as I missed the large halo. That's actually that's a pretty tough galaxy to see through an 8-inch scope. The scope now is at such a position that we're kind of losing our connection to it. All right, but we finally got our image, and this is NGC 1184, I do believe. Yes, and it looks like it's a galaxy. Let me clear the screen a little bit. Should be seeing a galaxy somewhere on the screen. However, this one's very far north, so it's possible we just are not tracking. And we're auto-connecting again. Let me give you the data. It's also known as UGC2583. It's at 3 hours, 16 minutes, 45 seconds, plus 80 degrees, 47 minutes, and 36 seconds. It's in Cepheus. It's a magnitude 12.4 galaxy. Should be quite obvious on the screen. 2.8 by 0.6, so near edge on. Average surface brightness of 12.9 with a position angle of 168. I cannot think of a reason why we wouldn't be seeing it somewhere on the screen. The visual magnitude is 12.5, surface brightness 12.9, and it says here dimension 2.8 by 0.6 arc minutes. So this baby should be quite obvious, and I can't tell you why it isn't. Let's just play with the histogram settings a little bit and get a sense of it. Are we seeing this anywhere? Let's see if we can get a zoom on it. I cannot declare that we are seeing a galaxy anywhere on the screen. I'm searching around. Something a little striate right about there. We don't have a zoom function, and that really revealed them in the ASI the ASI Studio is so good at zooming in. I am not seeing a galaxy. There's a little nebulosity here, but this should be pretty striking. I'm a little disappointed here in the fact we're not seeing it. So I'm going to move on to the next study, and hopefully we will be able to pick it out. Well, we should be seeing NGC1027 on the screen. Let me clear it out a little bit. Yeah. All right, here we go. Wow, there is a cluster here. It is composed of fairly faint stars. It's at 3 hours, 11 minutes, 41 seconds, plus 53 degrees, 20 minutes, 54 seconds. And Perseus, tiny, 2 arc minutes. Perhaps that. Okay, it's a type 2, 2P in Perseus. Magnitude 11.8, dimensions 2 arc minutes, yes! That's very faint for an open cluster. I can't imagine who managed to pick this one out, but it is considered a type 2, Roman numeral 2, moderate 2, average moderate brightness distribution P in Perseus. NGC 1220, we're going to go on to NGC 1245 now. NGC 1245 was an open cluster, and it was blocked. And let's see. Oh. Yeah, 75 stars in a dense cluster. Too bad we didn't make it out. Let me give you 1343. It should be a galaxy because it's UGC. It's at 3 hours, 37 minutes, 49.7 seconds, plus 42 degrees, 34 minutes, and 17 seconds. Visual magnitude 12.7, 2.6 by 1.6, so fairly oblate. Surface brightness of 14.1 with a position angle of 80 degrees. A 17.5-inch telescope in October of 1990. Says it's fairly faint, fairly small, large brighter core, extremely faint halo, elongated 2 to 1 east-west. There's a double star nearby. It's H2190, magnitude 1314, and 15 arc-second separation. It's off the northwest edge, 1 arc minute from the center. Galaxy type spiral bar with a lowercase p and peculiarities in Cassiopeia. Once again, magnitude 13.6, visual 12.8. So that must have been the blue-violet was 13.6, 12.8. So it means it's probably a spiral. It was a spiral. 14.2 magnitudes per square arc minute, dimension 2.6 by 1.6, with a position angle of 80 degrees. Come on, show me a galaxy tonight, will you please? Something faintish right in here. This is not good. I just do not get why we are not seeing our galaxies this evening. Let's push the brightness up, darkened it. Does appear to be something over here, but this is not obvious, folks. Very peculiar. I would have to attribute it to some kind of alignment issue. There's something up here, however, but that's in the wrong position. We're getting some nebulosity over here, apparently, or brightness variations. I can make no declarations about seeing this galaxy, which is NGC 3, 4, 3, and we should be making it out. Sorry, folks. Yeah, we're on a bad position for the antenna. I'll have to check it out. We're getting a bit of a blockage now for NGC 1348. It's an open cluster, 3 hours, 34 minutes, 9 seconds, plus 51 degrees, 25 minutes, and 12 seconds in Perseus. Size is 16 arc minutes, open cluster type 2, 2P. Right, and we already covered some of the data on this. Basically, we are getting some wall blockage on it. It's about 6 arc minutes in diameter. Let's have a clearer view of it. Could be a cluster over here. Very hard to tell. Alignment of 3 stars there. We're getting, as I said before, we're losing our connections. I'm going to have to check the antenna angle. So that is our not so good view of NGC 1348. Let's move on to NGC 1444. We are, boy, the sky is progressing west faster than I can head east, however. Looks like we're getting the wall on NGC 1444, so nothing to view here, folks. I'll give you the data. NGC 1444, 3 hours, 49 minutes, 26 seconds, plus 51 degrees, 39 minutes, 18 seconds in Perseus. Open cluster, visual magnitude 6.6. Small, 4 arc minutes in size. It's a type 4, 1P. So very disparate, but all the stars are of roughly the same magnitude in Perseus. 6.6 cumulative and 4 arc minutes in size. Boy, we are losing it fast, folks. So let's go on to 1469. It's a galaxy. Hopefully it's fairly far north. It's at 68 degrees. Let's see if we can actually pick out a galaxy. NGC 1469 coming up next. Well, NGC 1469 should be a galaxy in Camelopard, Dallas. Let's go ahead and reset the We're missing something here. It's the settings. Well, there's our zoom. Can't trust that because it could be anywhere on the screen. All right. NGC 1469, otherwise known as UGC 2909. Is a galaxy at 4 hours, 28 minutes, plus 68 degrees, 34 minutes, and 40 seconds in Camelopard, Dallas. Should be magnitude 12.7 with a size 2:1 aspect ratio, 1.9 by 0.8, and an average surface brightness of 13.1. Once again, we are being defied, and it must be an alignment issue. You need to get back to something that's further north and see whether or not it turns up. In a 17.5-inch scope done in November of 1991, moderately bright, fairly small, elongated 5.2, north-northwest to south-southeast, 1.5 by 0.6 arc minutes, very bright core surrounded by fainter, elongated halo. With the Rev 2 system, we should get a better view than that. Magnitude 10 stars just off the very bright core, surrounded by fainter, just off the west edge, 0.6 arc minutes, west-southwest from the center. It's a galaxy of the elliptical class, S0, so it's also the spiral 0, so it's on the cusp in Camelopard, Dallas. Blue-violet is 14.2, and visual is 13.2. That's a 1 degree, 1 magnitude delta, which is typical of elliptical spiral galaxies. Oh, I'm not seeing it anywhere on the screen, and I'm quite disappointed with that. We've been catching that all evening as we go further north. I'm almost to the point now where I should give up, but I probably should just capture the data for the evening. No galaxy present, and there's nothing I can do with the histology settings to improve on it. You know, I was seeing some really good galaxy detail. Well, there is something right in there using the ASI Studio. This ASI Air doesn't seem to be doing quite as well in revealing galaxies, or simply the alignment is that far off. Anyway, moving on. Well, this should be a bit of an acid test now. We're going after a planetary nebula. They typically have fairly bright average surface brightnesses. They're roundish and they display well on the screen. If we don't see the planetary nebula here, and we are right there. Okay, those galaxies should have turned up right about there on the screen. Here's our zoom, planetary nebula. You can see the central star. And we can see the annulus around it. We're clearly seeing it from the pole. I'll give you the data on NGC1027-1501 and go back a few on the galaxies that I had to skip, a few studies I had to skip over due to the fact that they were too far south. NGC1027-1501, called the Blue Oyster Nebula. It's at 4 hours, 6 minutes, 59.4 seconds, plus 60 degrees, 55 minutes, 15 seconds in Camelopard, Dallas. You can see it's quite bright, 11.9. Its size is slightly smaller than 1 arc minute, 56 by 48 arc seconds, with a position angle of 98 degrees. It's not telling me, what the central star is. Its blue-violet magnitude is 13.3, and its visual is 11.5, and its dimension is 0.87 arc minutes. Yes, indeed, we should have picked up those galaxies on the screen right about in this position, because this baby is plus 60 degrees. Let me tell you what we missed, however, before we go back and have a look at M82. So we missed NGC in terms of sky position. NGC 1491 at 4 degrees, 4 hours, 3 minutes, 13.6 seconds, plus 51 degrees, 1858. And Perseus was a 3x3 arc minute diffuse nebula or supernova remnant. We did get a good view of a nebula earlier in the evening. This one is in Perseus. Its dimension was 25 by 25 arc minutes. Should have filled about that much of the screen if we had gotten it. We also missed NGC 1496 at 4 hours, 4 minutes, 32 seconds, plus 52 degrees, 39 minutes, and 42 seconds in Perseus, a 6-minute arc minute sized open cluster, type 2-1P in Perseus, and it was magnitude 9.6, which meant it was probably fairly faint. We are getting a very good look at the planetary nebula. Zooming in on it. I can play with the histogram a little bit. Let's see what happens when we do that. The central star would be interesting to find out how bright it is. It's making it look more like an annulus there, so no matter where we set this thing, we made it disappear by excluding the light down there. Best view is probably right about in this setting here. Clear it out, central star. Annulus, faint nebulosity to the core. That's our last study in the Rounders series for this evening. We missed a whole bunch of galaxies, and I can't tell you why, except we will go ahead and look in this part of the screen on Manana, and I'll put a pointer there to help make that possible. All right, let's have a look at Messier 82 this time as our Carpe Noctem moment. Well, we do have Messier 82 on the screen and nicely set up, not towards the middle of the screen where I'd like it, but look at this nice view of 82 and 81. I'm going to go ahead and look at the break in it. Look at the texture across it. Fabulous views. How could we have missed those 12th and 13th magnitude galaxies? I could not tell you, because the average surface brightness on these babies has got to be somewhere around magnitude 12 or so. I'm going to go ahead and do a 30-second exposure and come back to it before we do our Carpe noctem moment. Clearly, we have to play with the histogram on this baby. Peek it out here, exclude all the light to the right, and boy. All right, let's put this over here. Take a look at its small scale. Look at the spiral extensions there. A bit pixelated, of course. We'll play with it. See if we can get rid of the pixelation by going off to the right. There we go. Aesthetics are a little better now. We still have spiral extensions. Now we'll go ahead and have a look at the normal size. Not bad screen position. Remember that this planetary nebula was located right about this position. So we've seen this much drift, which is about 30 arc minutes. Usually I don't see much more than 4 or 5 arc minutes drift with the Rev 2 system on the Gemini Plasma ND Gemini 2. Not sure whether I'll ever mount up the El Quattro 6-inch fast newt or not on that mount, but I probably will play with it. But after I've concluded the tour of the NGC catalog 45 degrees north and further south to minus 35. There is our Carpe Noctem view at magnification. And with that, I say Carpe Noctem.